The second part of 7.2 is about using the unit circle and putting those angles inside of a circle. This is going to allow us to expand the idea of trigonometry away from just looking at trigonometry in right triangles. We're going to start looking at trigonometry for angles that are bigger than an acute angle. So this is how the unit circle works. It has a radius of 1, and no matter where you are in the unit circle, your radius is 1, and there are 2 coordinates that are on the unit circle depending on what angle you are. So you can sweep out of that unit circle at any angle, and you're going to get different xy coordinates depending on which angle you sweep out at. Your radius will still be 1, but you can sweep out at any angle and create new xy coordinates. So that's what we're starting with in the unit circle, thinking about spinning this terminal side of our angle anywhere within the unit circle is going to create new xy coordinates. So our first example, we're going to take a measure of 60 degrees and a terminal side that intercepts the unit circle at xy. So we have, here's our initial side is going to be right here on the positive x-axis, so that's our initial side of our angle. And then we're going to have an angle of 60 degrees, so that's going to look kind of like this. And it's going to intercept the unit circle at some xy point. And this is part of why we spent so much time looking at right triangles, because I can drop that reference triangle in place, and I can figure out, based on that, the hypotenuse of that triangle is a radius of the circle. So the hypotenuse is 1, and this distance, the bottom edge of that triangle, is going to be whatever the x-coordinate is, and the vertical side of that triangle is going to be whatever the y-coordinate is. Since it's a special right triangle, it's a 60-degree angle and a 30-degree angle, we can figure out all of the missing sides of the triangle because we know that the short side is half of the length of the hypotenuse. So this side is 1/2, and that means that the x-coordinate is a half. And then the y-coordinate we know is the square root of 3 times a half. So the y-coordinate is square root of 3 over 2. Your timer's going off. Can you go to school? In the unit circle, we often use a different way of measuring angles. That way of measuring angles is called radians. So we're used to measuring angles in degrees, but radians is another way to measure angles. The definition of radian is if I sweep out an angle so that I've swept out a distance of 1 along the unit circle. So if this is a distance of 1, which is the same as the radius, then that's a radian. So if I go all the way around, it's sort of like a distance, right? So if I go all the way around the unit circle, then my radians would be equal to the distance around the unit circle. So the circle has so the formula for circumference is 2 pi r. So since the radius is 1, the distance around the unit circle is 2 pi. And what that means is that if I swing all the way around the unit circle, that would be 2 pi radians. I know that the number of degrees in the unit circle is no, it's not 180 degrees, I lied. It is 360 degrees. If I go all the way around the unit circle, that's 360 degrees. So if I want to convert back and forth between radians and degrees, I use that relationship. For example, I know that if I go halfway around the unit circle, that would be 180 degrees. And if I go halfway around the unit circle, that would be pi radians. So I know that 180 degrees is pi radians. And I can use that to convert back and forth for other degree measures. I'll show you how to do that. So if I have pi over 7 radians, I'm going to set up kind of a ratio here. So pi over 7 is the part of pi. Pi would be halfway around the unit circle. And in degrees, that would be 180 degrees. And I would like to know how many degrees it is halfway around the unit circle. I'm sorry, not halfway around the unit circle. Pi over 7 of the way around the unit circle. So pi over 7 over pi would be how much it is in radians, and then the other side of the fraction is how much in degrees. So in order to figure out what x is, I need to multiply by 180. I'm going to go ahead and do some simplifying here. So pi over 7 divided by pi is the same thing as pi over 7 times 1 over pi, because I can multiply by the reciprocal. And then I'm also going to multiply by 180, so I get x by itself. The pi's cancel, and I have 180 over 7. That's how many degrees I would have with pi over 7. And then radians. And then we can divide that number and get that as a decimal, or we can leave it like that. If I have 75 degrees, that means I can set up a ratio for 75 degrees. That would be 75 over 180. That's on the degree side of my equation. And then I don't know the number of radians out of pi. So I think I could reduce this fraction. So 5 goes into 75. It goes in 15 times. And 5 goes into 180. Let's see, 36 times. Sounds right. And if that's true, I can reduce even further because I think I could divide by 3. So that would be 5, and 3 goes in there 12 times. So 75 over 180 is the same thing as 5/12. So I'm going to do 5/12 equals x over pi, and in order to find x, all I need to do is multiply by pi. So I'm going to do that up here. X is 5/12 pi radians. All right. The last two you can try. I actually forgot to divide 180 divided by 7 so we could figure out what that was. And I know you guys have calculators, so I know you could do that yourselves as well. But for that first one, I would say that x is 25.7 degrees. All right. Generally in radians, we leave them as a fraction, and sometimes in degrees, we usually round to the nearest tenth. All right. So I'd recommend pausing and trying these on your own, but then come back. All right. So the first one, if I do 5 pi over 6, that's in radians, so that it would be pi if I were all the way around the circle, and halfway around the circle. And then I want to figure out the degrees, so that would be the number of degrees would be x out of 180, which is halfway around the circle. So then if I want to solve for x, I would multiply by 180, but first I notice that these pi's are going to cancel. So I have 5 over 6 times 180 equals x. I'm going to degrees, so I'm going to just go ahead and, well, I notice that 6 goes into 180 30 times, so it's going to be 5 times 30, which is actually a pretty nice number. That would be 150 degrees. So these are my answers so far. And then the last one, I'm doing 300 degrees, so that's going to be 300 out of 180 would be some number out of pi. So the left side is about degrees, the right side is about radians. I notice I can divide by 10 and get rid of those two zeros. I can divide by 3 and I get 10 over 6, and then I could divide by 2 and I get 5 over 3. So then I have 5 over 3 equals x over pi, and then I can multiply both sides by pi. So I'm going to do that up here. X is equal to 5/3 pi radians. So 300 degrees is the same thing as 5/3 pi, or 5 pi over 3 radians. All right, that is the way we're going to work. That's what you're going to be able to do today on the second part homework. Thanks so much. Bye.